Hello students, next topic is vapor pressure of liquid solutions. Now we will consider a solution of liquid in liquid. Now let us consider a binary solution of two volatile liquids and denote the two components by 1 and 2. Now when a solution of two volatile liquids is taken in a closed container, this is component 1 and this is component 2. So solution of two volatile liquids is taken in a closed container. Then since both the liquids are volatile, in the vapor phase also we have vapors of both the components. So in the vapor phase also vapors of 1 and 2 are present and a dynamic equilibrium exists between the vapor phase and the liquid phase. Now let us denote the total vapor pressure at this stage by P total, partial pressure of component 1 by P1 and partial pressure of component 2 by P2, mole fraction of component 1 by X1 and mole fraction of component 2 by X2. Now there is a quantitative relationship between the partial pressure and the mole fraction of the components, and this quantitative relationship is known as Raoult's law. Now, Raoult's law states that for a solution of volatile liquids, the partial vapor pressure of each component of the solution is directly proportional to its mole fraction present in solution. So, for component 1, the partial pressure due to component 1 is directly proportional to the mole fraction of component 1. And writing the proportionality constant is P1 naught. Proportionality constant is the vapor pressure of the pure component 1. So partial pressure of component 1 is equal to vapor pressure of pure component 1 into mole fraction of component 1. Similarly, for component 2, partial pressure of component 2 is equal to vapor pressure of pure component 2 multiplied by mole fraction of component 2. So this quantitative relation between the partial pressure of the component and the mole fraction of the given component is known as Raoult's law. Now next is the Dalton's law of partial pressure. According to the Dalton's law of partial pressure, the total pressure over a solution phase in the container, over a solution phase means the total vapor pressure over a solution phase in the container will be the sum of the partial pressures of the component of the solution, and it is given as total pressure is equal to sum of the partial pressures. Now putting the value of partial pressure, we get total pressure is equal to mole fraction of component 1 into vapor pressure of pure component 1 plus mole fraction of component 2 into vapor pressure of pure component 2. Now for binary solutions, mole fraction of component 1 plus mole fraction of component 2 is equal to 1. So mole fraction of component 1 will be equal to 1 minus mole fraction of component 2. Now putting the value of mole fraction of component 1 here in the equation and solving, we get total pressure is equal to vapor pressure of pure component 1 plus vapor pressure of pure component 2 minus vapor pressure of pure component 1 multiplied by mole fraction of component 2.